Okay, we're gonna finish up 3.6 here, and we left off with an exercise where we want to do the following things. We want to find the X and Y intercepts. We want to find the vertical asymptotes and the horizontal asymptotes. And we want to find the domain, and we want to find the range. So let's go ahead and start off with the X and Y intercepts here. So let's do the X-intercept. So for the X-intercept, we set Y to be 0, so we have 0 is equal to negative X plus 1 divided by 2X plus 4. And we multiply both sides by 2X plus 4, giving us 0 is equal to negative X plus 1. And essentially recall that if you want a fraction to be 0, the numerator has to be 0. And that's exactly what this equation says. So you get x equals 1 from this. Okay, so we have the point 1, 0. Then we go to the y-intercept, where we set x to be 0. So y equals 0 plus 1 over 2 times 0 plus 4. And we get y is equal to a fourth. So we have the point 0, 1/4 from that. And now we need to find our vertical asymptote. And that's just setting this denominator equal to 0. And so we get 2x plus, 2x is equal to minus 4, so x is minus 2. And that is our vertical asymptote. For our horizontal asymptote, so we have the equation negative x plus 1 over 2x plus 4. And I'm going to use what I call that method 1, where I multiply the top and the bottom by 1 over x. And what does this give me? This gives me negative 1 plus 1 over x divided by 2 plus 4 over x. And now notice what happens. So the question is, we want to send or imagine that x is becoming really, really large. Either really large on the positive infinite side or the negative infinite side. It ends up giving you the same end result. And in this case, these terms go to 0 because the denominator is becoming really, really large. And so this goes towards the value of negative 1/2. So our horizontal asymptote is negative 1/2. And so now let's do our graph based on this, and then we'll find the domain and the range. So we have, let me just summarize here. There was a point 1, 0, 0, 1/4. We had a vertical asymptote, x equals minus 2, horizontal asymptote of a negative 1/2. And so we go ahead and graph this. What do we get? Well, we have 1, 0 here. Plot the points in red. 0, 1/4 somewhere over here. We have a vertical asymptote, x equals minus 2. Right here. And we have a horizontal asymptote at y equals negative 1/2. So here's negative 1, here's negative 1/2, so it should be something like this. And you can see here that this part of the graph, the graph is always either exclusively above the asymptote, well, the majority, I should say. It's not always the case, but your graph is always essentially above or below the asymptote, at least for these examples. There are some peculiar cases which we're not going to talk about. But we can see here from this graph that this must be the case, that the graph goes up this way. We can't have, I guess if you wanted to, you could plug in one or two more points if this is not clear. So let's just to be kosher, what if we plugged in like -1? What would we get? We would get y is equal to -(-1 + 1) divided by 2 times -1 plus 4. And what would you get? You would get 2 on the top and 2 on the bottom, and you get 1 here. So you'd have a point here of -1, 1. So the graph is definitely going up this way on this side. So what we want to do, we don't have any points on the left of this asymptote. We can plug in maybe just 1 point at least. So here's x equals -3. Let's plug that in. What do we get? We get -3 plus 1 divided by 2 times -3 plus 4. We get 4 on the top, and we get -2 on the bottom, so we have -2. So -3 plots to -2 here. Go back to red. And so you're going to have a graph. As you approach a vertical asymptote, you always have to go to infinity. And as you approach x going to -infinity, so let me do a little, what I usually do here. So this piece says as x goes to 2 or to -2 to -2 from the left, y goes to -infinity. Okay, and this piece here analogously says as x goes to 2 from the right, y goes to +infinity. That's the vertical asymptote portion. This portion says as x goes to -infinity, y goes to the horizontal asymptote, which is -1/2. And on this side over here, as x goes to +infinity, y goes to -1/2. So those are kind of the graphical portion illustrating what exactly a vertical and horizontal asymptote are. And so the last portion here is our domain and range. And our domain, remember, is just remove x equals -2, right? Because that's where our vertical asymptote was. So we have -infinity to -2, as well as -2 to +infinity. And then our range, well, our range consists of all the possible y values. So recall that for the y values, as long as our graph is touched by a horizontal line, that y value is included. So every y value is included except the horizontal asymptote. So this is all y values except the horizontal asymptote, which in this case is just except y equals -1/2. So we end up with -infinity to -1/2 union -1/2 to +infinity. And that's our range, and that concludes this example. So there are some parts of this section that I didn't cover. So let me just make a couple of mentions about it. This is pretty much the end of our material, end of our part of 3.6 that we're going to cover. Let me make a couple of important points to mention. So one thing is, in general, a graph can cross the horizontal asymptote. We've never seen an example like this, but as you go along, if you go to higher degree polynomials, so I'm not saying this one definitely works out that well, but if you have p of x over q of x, where these are both degree 2, like you have an x squared term in it. Okay, if they're both degree 2, then there is a much more likely possibility of crossing a horizontal asymptote. That's one thing I wanted to make mention of, that we didn't talk about that and didn't do degree 2 polynomials, which if you do calculus, you'll definitely cover that. The second thing that I want to make mention of is that we didn't cover one specific case. So there's a case where a factor in the numerator is the same in the denominator. So for example, if we had, and this is 2x plus 4 over x plus 2, this is 2 times x plus 2 divided by x plus 2. And in this case, there's no vertical asymptote at x equals minus 2. What ends up happening is these kind of cancel. Okay, you still can't plug in x equals minus 2. So all that happens is you can think of this essentially as canceling. So you just equal 2. Sorry, not y. This, I guess we can call it y, but this equals 2 now. So this is the graph y equals 2 with a sort of gap at x equals minus 2. So the graph actually looks like, here's y equals 2, but then we just, at negative 2, we have a little gap. We leave a little, so let me draw that one more time. So we have y equals 2 here, but then we leave a little space because we cannot allow for x to actually equal minus 2. So this is the graph of y equals 2x plus 4 over x plus 2. There's no vertical asymptote. So this is also a case which we kind of didn't really talk a lot about, but it does arise, and I wanted to make mention of it. Okay, so that's pretty much it. But for us, again, we're not going to talk about this so much. These two little things. We can focus on the rest of the examples that we have done earlier. Okay, in the next video, we'll start the next section.